Hello, hello, hello. Welcome to Kubernetes and Enterprise Guide, third edition live stream. Uh, my name is Mark Borstein, CPO at Travel Security, and with me is Scott Sorovich. Scott, you want to give a quick intro?
Sure. I'm Scott Srowich. I'm a principal engineer at a tier one global bank.
Awesome. So let's see. Are we streaming everywhere? I think we might be broken on LinkedIn. Uh, hmm, Interesting. Okay, well, we'll do our best. Maybe we'll have to do that again next time. So last episode we started with networking and we talked a lot about networking and about a lot of the different services, but I mean saying networking Kubernetes is like saying running an app in Kubernetes, right? Like, oh, that's easy, you launch a pod, but a little more complicated, right, Scott?
Uh, Slightly. Yeah, definitely. And of course, all the flavors and options that you can pick, all the CNIs now are starting to add other features, meshes,
So,
down the line.
yeah. So what we're going to do is last time we talked a lot about headless services. And we started to dive into that lab. This time, I think we're just going to dive right into the books labs because that was actually one that wasn't in the book. Um, and we've got a lot in here, right? We got ingresses, we got services, we got load balancers. Real quick before we dive into the labs, do you want to maybe describe a little bit about what a service, a load balancer, and ingress is, and kind of how they relate to each other?
Yeah, I think 2 weeks ago we did kind of cover services though, right? Because we went through it pretty exhaustively, probably for some people, but the fact that pods are ephemeral IPs, you don't want to target those. So we said use a service, right, to kind of expose. And we talked about all the different service types, and that's where we got into cluster IP, node port, load balancer, and of course, like you said, headless, which there really is no such thing. It's cluster IP with assigning no IP. And that's what we did pretty extensively when we were showing how DNS is registered and how it's used in something like a Kafka or even a Cockroach DB deployment.
Right.
So ingress, though, is an interesting one because it's a term used in generic terms, right? Just meaning incoming traffic. So it does tend to throw off conversations I'm on. You say ingress to somebody and they're not a Kubernetes person. They're just thinking generic traffic. You say it to a Kubernetes person, they're thinking ingress controller.
Right.
It is incoming traffic. So it's all the term, kind of like namespace, right? When we get to Vault, we'll have a Vault namespace. Okay, we'll have a Kubernetes namespace. All these terms that mean the same thing. I'm sorry, different things, same term. So
Right.
yeah, so ingress is how we're going to talk about how we're going to get our traffic into the cluster, and we'll do it two different ways. Obviously at layers, we talked about networking 2 weeks ago. So at layer 7, we'll be talking about the Nginx ingress controller, which is great for workloads from 6 years ago. Don't get me wrong, still heavily used today, right? Right, but we have other workloads coming
Why are
over,
you
like
saying mean things about Ingress Nginx, Scott? I mean, come on, man.
it just took me so many years to get people that get that I do need to have like databases, right? So you just get this weird look of, oh, you don't need, an IP on layer 3. Ah, yeah, I do actually. So we'll talk about those two, right? One of our favorite parts of this chapter is MetalLB, right? Heavily used
Yeah.
out there. Tools like Anthos by Google have converted over to it. They used to have their own proprietary type of load balancer called Seesaw, and now they use MetalLB. It's included in most distros that I see, and if not, it's heavily documented by all the distros and how to use it. And we'll definitely talk about that, which will call out the limitations. I'm going to say limitations of how we do the labs, right? So MetalLB, to truly play with it, you've got to have real nodes, right? Not that you can't with something like a Kind or a Mini Kuber or anything else, but you get the whole nesting game that we run into, and that's the issue. So you try to hit a MetalLB address outside your Kind cluster, it's not going to work, and that's
Right.
just due to the networking that is nested. So that's why we don't ever in the exercises say go to a browser on another machine to hit this or telnet or do something to the port. If you notice, we do it all from the local station. We'll curl, for an example, Nginx web running on a load balancer, and we'll get the whole output. So the reason I think that's important is I got a message this week from somebody on LinkedIn asking about that. Right? They actually called out that, hey, you're not using the right ranges in your pool. It should be, say, 192, 168. I said, I knew exactly what the question was going. And I said,
Yeah.
you'd be absolutely right if we didn't have kind. And I do kind of explain this in the chapter a bit. There's a lot to explain on that. Right? But we'll kind of
Yeah,
talk
and
about
I
it.
gotta be honest, like especially when we get to Metal LB, we can dive into this more. Like Metal LB is magic to me. Like it's wizardry, it's sorcery, it's dark magic because I'm like, okay, here's an IP and it works, right? Like I don't have to set up an external load balancer of any kind. And like I know in my home lab, it's completely changed the way I've deployed clusters. It's so much easier now to go ahead and do that. So okay, so let's dive into it. So
Yeah.
I've got the book open and I am in chapter 4. And anybody who is watching online, please feel free to ask a question. We'll go ahead and respond as best we can. Yeah, let's go ahead and so we start off with services, and the first thing we do is we create a deployment called Nginx Frontend. So I'm not going to dive into that, but let's take a look at the services that we do have running. So I'm going to present,
Yeah.
share screen, entire screen. I know technology goodly. So I've got a VM here, and this VM is running our kind cluster from chapter 2. Almost all of our chapters, the first step is deploy a kind cluster. Super useful, and quite honestly, I use it a lot, even if I'm just doing a demo or something and I don't want to go through the pain of setting up a bare metal cluster. So if we do kube control, get namespace, we already have Nginx in there. And I don't think we're doing node port. I think for that we're doing host containers. Press
Yeah, I
Nginx.
think.
No, we got one node port. So the
We
ingress
do.
controller.
If you
Yeah.
were to take a look, the mark at the deployment for Nginx, you would see the config. Now we've had a couple editions of the book. That's why I'm trying to rewind my thought process, because I did update a couple things from that. If it's following what I recall doing, apologies for me on this, but I'm looking at a quick cluster over here at home. If I look at the, let's see. Yes. So if you were to look at that, look at the deployment goal, look for ports, or if you actually scroll down, you're getting closer. What we're doing to make this easier in the labs, as Mark was calling out here, the service that Mark just showed wouldn't actually work externally, right? Because it's cluster IP. It's only going to work in the cluster. In the ports, you're going to notice container port 80, host port 80. So what we're doing with this deployment is telling it to expose itself directly on the host port of 80 and 443, right? We got them both.
Yeah, and the reason we do that is because of the layered nesting dolls, right? Like that's really what that boils down to.
It does. Plus, honestly, to make it externally accessible, you'd need a load balancer, and at this
Right.
point, we don't even have one. So there's kind of a what we're playing with, chicken and egg kind of issue, and this
Right.
did make it easier to say, okay, cool, let's just expose it right on there, and it just works, right?
Yeah.
So this is how we're doing it. Yeah, we could have done it a couple different ways, but this is definitely the easiest way that I came up with when we were designing.
Yeah, that makes sense. So we talk a little bit here. So should I let me see here. Should I just remove our Nginx one? Because I think you have a couple of examples in here, right?
When you say the Nginx one, sorry. Mark,
So because we have, I don't want that there. I want that. Oh, There we go. Nobody wants to see my Mac toolbar. So if I do a query, I'm in chapter 4, I think. Yep. So
Oh,
in
yeah.
ingress, there's nginx remove. You
Ah,
want me to go ahead and run that?
no. So that actually, if you were to look at the other one first, nginx ingress. So what this is for, I think, this is for an actual ingress rule, actually, Mark. So if you were to look at that, the shell, yeah. So you see here what we're deploying. This is just to show a service deployment using ingress, right? So the reason I have a remove one is you can delete the pod and all the services with it. So if you're taking a look at this, you can see all we're doing in this one is we're going to deploy nginx, right? And it's pretty heavily documented, to be honest. And we're using nip.io, so probably a good point here to bring that up too, right, Mark, as we do this. So
Yeah.
do a clear, execute that script,
Um,
the nginx
so wait a
ingress.
minute. So because we already have nginx running in this.
Right. This is not nginx controller. This is a ingress example.
Gotcha. All right.
Yeah. So I think you're looking at it. This isn't like the SEO chapter where we have to rip it out.
Gotcha. Now, should I update? Because like you've got some rules in here for. Oh, okay. So you pull the host IP. All right.
I do
Cool.
as well. Well, we can get into that when you see it. Yeah, because we added this really in the 3rd edition mostly.
Yeah. So it's pulling that up. All
So you can see
right.
from the output, if you're looking at this, it's telling you what the IP is found. And the reason this is important is nip.io. Okay, so if anybody on the watching or watching later hasn't used nip.io, it's just a way to create host names, right, for your local deployment. Of course, you need an internet connection. And as Mark's showing here, it works, right? We didn't have to register any names, but because of the way this looks up, and that's why your IP is in every URL, right? Because
right.
nip.io says, oh, okay, that's what you want. Go back to the source.
Yeah.
But getting names, without this, how do you play with ingress rules, right? You need to be able to do something with unique names.
Yeah, that's definitely an issue that we ran into when we came into it. Because like, what's the first adage of any kind of problem solving? Well, it's DNS, right? It's always DNS. And
Yeah.
I think that's that's always true. Like just rebuilt my home lab, and I got to tell you, DNS was one of the biggest pains getting it working.
Well, you got multiple DNSs,
so,
right? We don't really get into it in
yeah,
these chapters, but you've got Kubernetes and you got your edge DNSs. There's quite a bit.
core DNS, and it's one of those things that if you don't have a way to do DNS, it can make your life so much harder. And being able to use something like nip.io. Now, if you are running these exercises from within a corporate environment, nip.io might get blocked. There is also this is one I learned. So my home lab now runs OPN Sense as the firewall. And so I think it's the rebind. You've got to disable rebind protection in order to make nip.io work for your IP range. Because unfortunately, the malware makers like to use nip.io as well. And this is why we cannot have nice things.
So redirect, so yeah, flags, right?
Yeah. So you got to be a little careful, but honestly, unless you have a DNS server. Now, what I like to do in my lab is, like I said, I'm running OPN Sense. OPN Sense supports both unbound DNS and open DNS. I run unbound DNS, so you can add aliases. Most home routers have some kind of support for overriding DNS, whether it's DNS mask or DNS mask, unbound DNS, whatever. Like even the commercial home routers will often have something buried in there that lets you override DNS.
There's a lot of ways to do this. We didn't for the book mainly because the entry that everybody had. DNS mask was a great idea. We were going to do that for anybody on the call that's dealt with that. But you got to set, of course, your machine now to point to your DNS mask as the main DNS, and then you forward from that. And we have added instructions in the GitHub on how to do that. However, the labs and the exercises, I should call them, are all based on NIT.io for that. So if you ran this one and you're running DNS mask, you're going to get different addresses. It's a tough decision on which one to do. We had to make it easy for everybody to just say, cool, I want Kubernetes. And that's where NIT.io comes in. But as Mark called out, it's bitten me where I'm on a plane. And I'm like, I'm going to do something. And I'm like, oh, I can't. Right. So I could edit my host file and enter these manually on a plane, but it's kind of a pain. But
and even then, if you did that manually, if you have anything that's running, because this is why DNS becomes so important. If you have anything that's running inside the cluster that has to do a hairpin, now you run into the same issue. So NIP.io is, especially when you're doing these types of labs, is super helpful.
Yep. Yeah, so what we do in here for everybody is it's kind of broken out. We do a shell script because of the nip.io, right? So you'll notice this in a couple of our scripts where we have almost like a template. So if you could just ls this directory real quick, Mark.
I keep
just
because
you probably got, what, 3 files in here or 4, right? Yeah. Just kind of look at the ingress.yaml. So what you're going to see in here, everybody, is you see that host is webserver.hostip.nip.io. This is why we have shell scripts when you see an ingress rule. You might be thinking, what the hell are they doing that for? Because it's just this. Well, I need to get that host IP. So we parse that, pass it over, do it kind of a replace, is what I'm going to call it right here. So it puts the IP in there. Right, so just in case you ever have to edit these or something. So aside from that, standard ingress resource, right? Going through the rules. Again, like we've called out many times throughout the first 4 chapters, is we didn't create the book to go through over all the basics of, hey, here's an ingress, here's every option you can do. There's a lot of books out there for that, right? And if not, Kubernetes IO site has what you need for that basic. Like if you really don't know, use kube control explain. Right, explain command, by the way, if anybody hasn't used it, is just awesome because it goes through each part. So what we're doing in this, as we've mentioned before, is that service is a key point, right? The key values. So this ingress rule will tie to anything that's running with a service tag of name nginx web. And that's our deployment when we did it. So yeah, you can get out of this one, Mark. So this may probably not new for most people on this, right? I mean, ingress is pretty common. It's one of the first examples you see when you're playing around Kubernetes. I remember it being one of the coolest things when I ran Nginx and said, wow, look at that. I've got a...
And I think one of the things that's really important to understand is that an ingress controller is just a web server reverse proxy, right? Like it's a web server. We got Kafka back. He's becoming a regular. Bonjour, my friend.
Oh, cool.
Please excuse my ferocious butchering of the French language. A beautiful language that I am absolutely so. Side note: I went to France for KubeCon last year, and my wife was like, you should say bonjour to everybody. I'm like, well, I want them to realize I'm an American, so that they know to speak English to me. My wife was like, you wouldn't need. You could have, other than tattooing an American flag across your forehead, I don't think anybody would mistake you for not being American. I'm like, okay, that's a fair point. But
so I just wear a baseball hat. People flag me right away. Oh, you must be from the U.S. I'm like, yeah, I got to have them. But yeah, and I think last week we were talking about that, right, Mark? We were bringing up the examples about Nginx for reverse proxy, Apache. We brought up a couple of examples.
Yeah, and so I'm multitasking here a little bit. I'm launching we're going to do Metal LB a little later on, and I'm realizing we need a real VM for that. So I'm actually just going to launch a Talos cluster real quick.
Well, we don't really. What do you? The exercises
Do we
in the
need
book
a?
don't. Mm-mm.
Do
Well,
the labs?
to
Don't,
do
okay,
it,
cool. Then
we could, Mark. Right? In that case, you could hit it from another machine, but we won't do that through the exercises. So we have some examples.
oh,
And here's
okay, cool. Never mind. Okay, I
yeah, and
can
I can explain what we're
stop
doing in that.
multitasking.
Yeah, because I wrote that up. I wrote
Okay,
that script.
cool.
So
That
yeah, let's because of
runs
time,
in.
right? Most of us we have time to cover the metal LB because there's a lot in there and there could be questions.
Yeah. So we've talked a little bit about ingress and creating an ingress. So next, the chapter gets into using DNS to resolve services. Do you want to
Just
talk a little bit about like how DNS and services, because services are kind of interesting to me because they're sort of a load balancer, they're sort of a DNS alias. I think Tim Hawkin once referred to the service API as the worst API in Kubernetes. I don't think I'm misquoting him. Yeah, no, that's totally spam. Sorry, somebody in somebody's
always
anyway.
got something. So
Yeah. So talk a little bit about the service API, because that one really drives me up a wall.
talk about the service API. You're going on a total tangent here.
Us
Mark, in
tangents, that's
what way?
crazy.
Because you were talking about DNS first.
Right. So I mean, so what's the relationship between services, DNS? Oops.
Well, there really isn't, as per se. I shouldn't say that, right? So of course, you want to do, as we've always said, you don't want to map to IPs. We did mention 2 weeks ago that services have a fairly stable IP. We say fairly, right? Because if you delete it and recreate it, you could get a new IP. So even with that kind of stable IP, you should always target names, right? It's just typical connecting 101. If you can avoid IPs for all costs, just because changes can become a nightmare.
Right.
So yeah, you can see in this case, Mark's pulling up just the services that happen to be in ingress nginx, which is 2 of them, the admission controller and the main, right? One's a node port setup, one happens to be a cluster IP. Okay, great. So these just will tie to the backend pods, right? So if you were to pull up, let's pull up the nginx one, right? Mark the main one, not the admission, but the main controller.
What do you want me to pull up? The pod or the deployment?
Yeah, just gonna edit the service.
Oh, the service. Okay.
Yeah, just so we can look at it, right? Yeah, you can always output that to YAML and. Yeah, so I mean, there's a lot in here, right? More than there would be in a normal manifest because Kubernetes puts all of its stuff in here. So just kind of going over it quickly, the cluster IPs all get assigned, the family IP4, blah, blah, blah. So main thing is going to be the ports, right? So this says, okay, for my app, use this port. And you'll find 2 ports, right? Or in our case, we got node ports too, but let's not even talk about that one. So you get port and the target ports. We're doing HTTPS, HTTP, because this is ingress controller, right? So we're doing those. And, there's a type for the node port. So this is all in the status, which is great to look at once something's actually deployed, right? So again, not dwelling too much on services, but this will tie then to the pods that are running the correct labels, which I'm guessing we're only running 1 pod, right? In production, you'd have 3 minimum, but for resources, 1 is good for what we're doing. So you probably aren't going to target this by name as per se. There is an interesting service though that I've never seen it not included, right? It's in a base Kubernetes. So I exit out of this, Mark, and do a get services and default namespace. So what we're looking at here is in the default namespace, and there it is. So you got Kubernetes. Now the nginx web is from us playing a little bit ago. You can see by 13 minutes. We just put it in there for the test. So what's this one? Well, this is going to be the cluster IP for the Kubernetes API. So if you take a look at this, yeah, you're probably better off doing an edit on it, Mark.
I like to do just
You like doing it this way?
because I'm not
No, you're not going to change it, but yeah.
I'm not going to change it, and also I'm not on I'm SSH'd in, so it's not like it's going to pop up in a code terminal, which is easier to read.
Yeah.
So
Yeah.
I find this to be a little bit easier.
So what we can
But,
see in
you
here,
know.
like the target port might look familiar to people, 6443, pretty common when you see that on a lot of distros of Kubernetes, right? That's what the API is on. We're entering on the service is made for 443 to make it easy. And then it'll route back to those. So this is one of those services you'll see on every cluster in the default namespace. So this might be one of those names you use, right? Vendors will do this. They might have something that needs to query it. Well, if there wasn't a standard service, they'd have to create one, right? Or try to. Instead, they just say, cool, piggyback on Kubernetes default. And in this case, .cluster.local, I think is what we're calling this still. So every service that you create does get registered in DNS, right? We kind of talked about this 2 weeks ago. Pods don't, unless you're doing headless service, but services will. And they can be queried. You probably don't have any tools on this right now, Mark, is where I use NetShoot, right?
Yeah, and one thing that you mentioned there that I think is super important is you just tossed in that cluster.local. Talk about that for a second. What does that mean, cluster.local?
It depends who you talk to. Probably it means nothing to most people because you never change it. Now, there are reasons that you should. So by default, cluster.local is what I've seen every distro use. I'm sure there's some that have changed this over the years, right? But most people.
But what is it? Like what? Yeah.
Well, it's a good point.
I'm not a networking expert, right? Like what does that represent as part of the DNS entry?
Well, yeah. So it's essentially the name of the cluster. So it's going to be I guess when you're looking at the syntax of it, you'll say it's almost the domain URL portion of it, right? So it's the last part. So instead of, Kubernetes.io, Microsoft.com, it's cluster.local. So that is the ending of the suffix for what you'll be using for everything in your cluster. Now, it might be the same for all. I'm going to tell you it is on most things I've used. 200 clusters, same name. But of course, Kubernetes is using that DNS for just its local cluster. So where does this get into a problem, though? If you start trying to go cross-cluster things with add-ons like Submariner, you might run into problems with having the same names. Because if you're trying to do a global DNS across all of them, and everything ends in cluster.local, and you use the same namespace and the same deployment names, they're not unique entries.
Right.
So you could. Now there's other ways around this, right? You can actually have another designation depending on the app you're deploying. So if you're doing cross-cluster Istio, you get into a much more complex. This also has a problem with CIDR ranges, but again, let's not muddy the waters too much yet on that. So you could name them. You name it during deployment, whatever configuration files you have, and that becomes the suffix that you use. 9 times out of 10, people don't even see it because it's going to add that, right? So when you're calling it a service by DNS, you're going to call the service name dot namespace name. Now, the .cluster.local will be assumed. So I kind of just mentioned that because people might not realize, but on the internet, even www.amazon.com, you could put a period at the end.
Right.
If you don't, doesn't matter, but it's assumed.
Right.
And what is that period? Root, right? The DNS server hierarchy structure. So certain things are assumed and defaulted, and that's how cluster.local is too, or the name of the cluster.
Yeah, I mean, I know like when I first got started with Kubernetes and OpenShift, running OpenShift 3. Yeah, it was OpenShift 3 when you would deploy it via Ansible. It got really unhappy if you didn't reference things by cluster.local. I ran into a lot of problems. It's something I haven't run into a lot lately. I know like when I write stuff that references, for instance, the Kubernetes service, I don't add the cluster.local at the end. I just do Kubernetes.service. And it's been a long time since I've run into a problem, but I definitely do run into them from now and every now and then because it's always DNS.
DNS, like you were saying earlier, is definitely an issue, especially if DNS has latency too, right? We've had those issues. And so yeah, if you got a service running in namespace A and you're going to go to namespace C, assuming of course you don't have policies across and everything can talk, that's when you want to start using the service names. However, of course, now if your core DNS has a latency issue, could be disk, right? Whatever happens to be causing that latency, network, disk, whatever, you start getting weird errors. And I know, Mark, we've dealt with this in the past on other deployments where it's like the errors are weird. It's not like Kubernetes can come back and say, etcd latency is your problem. You just get weird failures. And trying to trace that can be a difficult process. So yeah, I mean, everything in services gets registered. That's great. You can query it from all over. So if you got Kafka running in a Kafka namespace, you've got something else for, I don't know, it's going to consume that. Of course, namespace B, you're going to reference it through the connector, and you're going to look for Kafka.Kafka. Sorry, horrible examples, but we'll say it's called Kafka for the service, Kafka for the namespace. So the real key point to always know it's the service dot namespace dot and then cluster. Those names do change a bit, like we showed 2 weeks ago with headless, right? Because that actually had a pod IP name, service name, namespace name.
Right.
So it's DNS, right? DNS sounds like a real simple thing. If anybody's played with DNS on the edge, and you start playing with different service records, you start playing with Kerberos records.
Kerberos. So now you're really starting to scare people away.
Oh, we start getting into all those little underscores and the 10 different domains, and yeah. So it can get quite complex. But for the purposes of what I think everybody needs here to know, services get registered, use them by name, right, rather than using IPs for those.
Yeah. And I think one of the things that Kubernetes does super well is, as long as it's working, DNS and Kubernetes is like rock solid. Like it was a core, back in the kubedns days before it migrated over to core DNS. I mean, but it's always been a core part, is making sure that the naming is there to make it simple to name it consistent. And once we start getting into future chapters, I think we'll start seeing this really in chapter 5 when we start talking about authentication. We deploy Open Unison, where there's some crosstalk between different services, and then really kicks off once we get into multi-tenancy and vCluster and Vault, where we're running lots of different services in cluster, and you got to communicate with all these things. You don't want to be messing with pod IPs. You don't want to be, you stick with the naming convention.
A lot for it. Mark, you mentioned a key point here, core DNS, right?
Yep.
So all your pods, everybody, when you're running this, they're going to get the core DNS, what they're going to point to by default. Okay, but you can still resolve external names. So the question is really how. So if you could exit this real quick, Mark, and if you look at services in kube system, Mark, you'll see, of course, a core DNS. So all your clusters have this, everybody out there. So in your kube system, you'll find a core DNS, as Mark said, used to be called kube DNS, depending what you're deploying. It might still say kube DNS, it's actually core DNS, right? It's just they kept the old name, kind of confusing. And you'll see in here, we've got 2 core DNS. Now, there's a config map. Mark, if you look at the core DNS config map. Now, this is something we'll talk about in external DNS. Right, so if we're looking here, you'll see there. So just take a look at that core DNS one. So this is how your core DNS is configured in your cluster, and pretty much all defaulted to what we're going to see here, right? Not a ton of config to it, but there doesn't need to be.
I cannot
type. Horrible typing today.
I really okay, there we go. So here's the config.
You'll even see now Kubernetes. You'll see cluster.local, saying, hey, that's this domain. That's what we're in, cluster.local. Key point in this is really going to be that forward. So we'll resolve anything cluster.local in core DNS. Anything that isn't in core DNS will then go to the forward, which is saying go to etcresolve.conf, which is then populated from your host in most cases, right? So if you ever exec into a pod and then looked at your etc resolve, you'll see this in there. Now, you can see not a lot in here for what we're doing, right? This is a standard one. There are times that you will potentially edit stuff like this. And we'll talk about stuff like that in external DNS or heck, KGB, for an example. So I don't like editing this if I don't have to. There are...
Because isn't this one that's provided by the distribution? Like this is one that would get overwritten on an upgrade, right?
Yes, it depends how the upgrade works. Yeah, there are those ones that just default back to the opinionated vendor file. Kind of like if you're using Falco, going way on a tangent, but they say never modify the base rule set because they update that, which means you're going to lose your rules. So there's times you can't avoid it. I've had to do it. We just write some automation, right? Okay, check the file. Oh, this isn't in there. Cool, patch it. We get our config. It not the best way, but hey, it works if you have to. So it's just one of those files people may not have looked at.
Most enterprise IT systems are built in. It's not the best way, but it works. So
well,
I mean,
tape, gum, all good, right? I like this question. I'm gonna have to show it up here.
cloning,
wow,
right? You got cloning set up for you, right? I've got like 4 of me running around.
I 3D print
no,
a lot,
I don't think
right?
the world would be okay with 4 of me or 2 of me. Really has a hard enough time with 1 of me.
Absolutely. No, this is a great question, though. I like it. I actually say part of it's being a geek. To be dead honest, too, when I started learning Kubernetes 7 years ago, a very understanding wife didn't hurt because I would work all day job, and then I jumped right into Kubernetes trying to learn it. And I tend to get consumed. Next thing you know, it's midnight. I'm like, oh, wait, my wife's probably in bed. I didn't get to see her. So it's a process, and it does help. Let's be honest, that my day job is Kubernetes. So that's not to say I have time to play, right? But you're always doing something. There's no good answer, I don't think, Mark, on your side.
Well, and I think you hit a big part of why this book is really unique is that Kubernetes is both of our day jobs, right? So like we're not just like, hey, here's this cool thing you can do. It's like, no, we're in the trenches. We're living and breathing this stuff. And so I think that makes a really big difference when you start talking about these different technologies and it's like what's possible versus like, well, yeah, you could do that, but nobody's going to. And so being able to like being able to use this stuff in the real world and have users actually banging on it and knowing what those implications are. It's a big deal. Like it's no small matter being able to bring that experience to the table. And I think it really shines here in the book.
Well, and that's why we actually decided to write one, right? Because we couldn't find some of the details that we didn't know or that we just wanted to take a look at. We said, okay, cool. Nobody else covers this. Let's just do it ourselves. It's the idea of people would always joke if you can't do, teach. So I actually was for many years a Microsoft trainer for the MCSE classes. As part of that, my training center, I did field service, not on a regular basis, right? You can only do so much, but training. But about a week a month on the average, I was out in the field. And the reason was when you go in to teach then, it wasn't just making up theories that didn't work. It was actually, I was at a customer site. Never who, it was just,
right.
We had to deal with this. And it reinforces it more, right? And a lot of people can learn from a book and teach it, but can they implement? So yeah, it also helps you like what we do, right? It's very lucky, but
yeah.
So sorry, we're running into time. I want to do Metal LB.
We're getting there.
Framework.
We've actually covered. I'm scanning ahead. We've actually covered a lot of the stuff in here over the last 2 days. Maybe just a real quick, because I want to get to the Metal LB lab
Yep.
in the last, maybe 10 minutes before we go. So, we've talked about services. We've talked about DNS. Talk about load balancers real quick. I'm going to put you on the clock here. Let's keep it at about 5 minutes. Like what is the load balancer in the Kubernetes world?
Well, that you kind of get two questions on there, remember, two answers. You said it yourself, services can do this. So there's going to be two ways to answer that. I'm going to take it from the respect of load balancers in general, not just load balancing, right? If that makes sense, and I'm going to cut that. So we kind of talked about this before, especially external load balancers, where we talked about the API server and that. So we won't. I'm not going to talk about those a lot, just because it does get to be external, and you got HA proxy, F5. There's just a ton of them out there. Now, when you get into Kubernetes, we kind of need that because we're dealing with L7 traffic in all of this, right? Ingress. So.
And you're talking about OSI layer 7?
OSI layers, yes. So the layer 7 traffic up at the application layer, where you're I want to say limited, but on purpose limited, right? Certain protocols talk in that layer, some don't. So you've got, HTTP, you've got gRPC, right? There's some other ones. That really gets into your wheelhouse, I think, a lot. Marcus, you do a lot of web stuff, whereas I come from distributed compute, VMs, physicals. I deal a lot in layer 3. So I need to get lower in that stack, and that's where you need to have like the load balancer type. So I always load balancers can do a lot, right? But they can also be pretty simple. What do you really want in a load balancer? You want to be able to say, this IP goes to here. Okay, it's a traffic director. I call them dumb load balancers, but there's a lot to those. You can add other features to them too. But we want to say, here's what we call a virtual IP, the VIP. Right, so you hear that term a lot, the VIP, and we're going to do this Metal LB. So what we're going to do is assign a live address on our network that says, cool, if you're looking for this, the load balancer is going to hear that request because it maintains a table of all these dips and says, oh, cool, if you're looking for .1, you want to go to this. If you're looking for .5, you got to go to this, down the line. Now, it might only load balance to one pod. It's not really load balancing though, right? It's just going to one pod. It's a redirector, but it can go. Typically, what you see these used for in the corporate world, of course, is production DR. Very common for that, right? You're going to get a generic address, which is going to call a global load balancer address, GSLB. And you're going to go between production and prod based on availability, maybe hot, down the line. Now, load balancer, like from a services standpoint, is, as we mentioned, you can tie it to a label, and you might have 10 pods running. Well, when you hit that service name, Kubernetes, by default, uses a round robin of, cool, 1, 2, 3, 4, 5, in theory, right? It doesn't always follow that. They say round robin, but it should follow in that order. There's other settings you can set on it too, right? Same with the load balancer types. You can say, okay, do it this way. Heck, you can get so complex in a load balancer type, you can do it based on GeoIPs to do some things to say, okay, cool, you're coming in. You got a NAP that's global, US, UK.
And I'm going to cut you off a little bit because I know we do global load balancing in the next chapter.
We will.
And I want to make sure we get to the end of this one. I know
let's go Metal LB, guys.
So much going on. So one of the things that I love about Metal LB is the fact that it just gives you IPs. And like, you don't have to set up something external like that. That's seriously, that's just magic to me.
It's almost like a DHCP server in a way. I hate to say it like that, but
yeah. And it just, it makes it so much easier. All right. So I'm going to go ahead. If anybody's actually watching and has their book open, I'm on page 117. And we're going to dive right into the Metal LB lab. So you want me to start with a new cluster. So I'm going to do delete.
You know what, Mike? You don't have to on this because this cluster is pretty
clean. You don't think so? Okay.
Yeah, we're good. Just save the time.
Okay.
Just LS this because you're probably not in the Metal LB directory, I'm guessing.
Probably not. I'm also not on the right window. So
so go up one and go down to Metal LB.
Right. Okay. Cool. So So I'm going to go into Metal LB.
So what we've done in here for everybody is there's a lot of templates in this, right? So these are all the resources we need, but we've created this script that will deploy everything, right? So what you're going to wind up with when you're done here is going to be the operator and the controller and speakers. So what we're waiting for here is for everything to come up. All right, so we just got a little wait on this. Yep, coming up, it's saying here's what we're using for your pool. And finally, it says done. Right. So I really, when I created this, I use MetalLB a lot, kind of like what Mark said. I tend to even bypass ingress a lot for my home stuff. I have a wildcard domain that I have my own Edge DNS servers, and I forward it all over, and I register the names dynamically. So we get into that later. So you see here, we have 2 speakers, 1 controller. Why 2 speakers? We have 2 nodes. Right, we got the control plane node, and we've got the I'm going to call it user, but worker node. So if we, so if you look at your nodes real quick, Mark, cool. Yep. So we got these. Look at the namespace again, Mark. So it's a MetalLB-system. Earlier releases didn't have the dash system, but that's become pretty common. So what do these do? About the controller, we go through this in the book, right? So you can kind of read more about those. The controller watches for things that are going to want load balancer type. And based on that, it says, oh, wait, you're looking for a layer 3 IP. Cool. Let's go assign it. Now, if you would, in your directory here, real fast, Mark, ls-layit, so we can see it in the list. A little bit more. Okay, so a lot in this. We're going to skip a lot of these templates, right? So the pool is exactly what it sounds like. What address range do you want to hand out? You can hand out multiples, and then you can use annotations in your service to pick from a different pool. So why do you want that? You might have multi-home servers, right? There might be reasons. It's probably not the most common. I've done it in DMZs. Let's not get into those details. There's a lot more to think about there. Because you've got management network to make sure nothing ever crosses, and you might want a certain thing running, not on the web front end, right? That could just be an attack vector. So you want to put it on the right one. What's a little bit different in here and newer, by the way, if you happen to read the 2nd edition versus the 3rd edition. 2nd edition, I don't believe, had L2 advertisement. That's a new custom resource. This goes in the OSI model. MetalLB can do your layer 3 one of 2 ways. It can do it in layer 2, again, OSI model, or BGP, Border Gate Protocol. Now, we use L2. There's a reason for that, right? In order to use BGP, you'd have to have BGP equipment at home. Plus there's work. You got to do BGP, what they call peering. Okay. Now there's big advantages to BGP, just the way it announces stuff. So we're going to kind of skip BGP. Again, it's cool if you're a Ubiquity fan. I know Mark and I have talked about this. I'm a big Ubiquity fan. They support BGP, right? So at home, I've done BGP just to play with it. So this is how the routing tables will be updated. And again, this gets into a lot of networking. So apologies if you're newer to networking and haven't played with that. But the way routers are set up, they have to learn routes, right, between. So we need to know where those IPs are. So we do layer 2 for the examples. That's why we have an L2 advertisement. Okay, if you did BGP, you would not need that. But you can do different things with the advertisement. You can say only announce these, or you could say only these 4 nodes can announce this L2. So there's a lot to that, but the speaker. The speaker is what announces, hence the name, speaker. Kind of cool when they name it this, right? You look at it and go, speaker. Oh, cool. It makes noise. It does. So when the operator says, hey, Mark's got a service called Kafka. It's a load balancer. Let's give it this IP. The speaker, and I say speaker, only one speaker owns that IP at a time. Now, it does kind of get distributed across all the multiple speakers, but let's assume your address ended in .10. Okay, so that is going to do what we call an ARP. ARP is, again, a networking term saying announce this. It's going to say, okay, cool, the .10 address, I own it. What's in that ARP? So quickly on networking, if you try to get a ping a DNS name, right? DNS is first. It resolves the DNS name to an IP address, right? So now we're jumping into, say, layer 3. Computers don't talk at IP. Okay, they talk at MAC level address, right? So if you've seen the MAC addresses, the hexadecimal, there's what, 6 sets of numbers in that. So the ARP says, here's that IP, here's my MAC address of the speaker or the host, the one that's announcing it. So all of those are, that's why we call them VIPs, virtual IPs. Because even though the speaker's announcing it, it knows it's on this MAC, the workload's not on there, right? The workload's on another node somewhere in the cluster, and it's going to forward it. And that's what this is going to do for us. So what we've done here so far is, deployed NLB. In the book, we have a couple of examples of the logs, right? We could show that where you see how the IP was assigned. It's showing you what it was. Key point on that first thing I mentioned, though, is one node or one speaker has that IP. If that pod goes down, another speaker will pick up that IP and announce it. However, it can take about 5 seconds. Okay, now I bring that up for reasons. That's downtime, right? You might think this sounds bad, but it's not. Even cloud load balancers take time to update. There's a reason for that. The last thing you want is I'm going to say a 2 millisecond update, right? You're going to denial of service everything with announcements everywhere. So there has to be that I'm going to say balance between not flooding and actually making things work highly resilient. Yeah, you may not have one in here. We haven't even created a service on it right yet, Mark.
Oh, okay. We haven't done that yet.
Yeah. So let's go back to the LS on here real quick, Mark, because there is. So right now we've got MetaLB, so we now fully support having Kubernetes load balancer services. And in this case, we have, that's right, Nginx LB. So we have something that was created. I do this at the end of the script, actually. So that's the cluster IP, which of course you won't be able to get to.
Oh, right.
Because that's cluster IP. Yeah, you want the one next to it. So if we curl this, it's running Nginx. There's our Nginx welcome page. Okay, now the IP mark hit here, 172.18. That is actually the Docker network IP range that kind is running on. The script actually finds that for you. Okay, this goes to my statement at the beginning of the call, where I said somebody hit me and said, hey, your IP range should be this and this. It can't be because of the way networking works with Docker, right? So our Kubernetes node is in a container. We really can't announce our live IP. Let's say you do have 192.168, which every home router hands out. Your container doesn't have that, right? That's your host. So I kind of explained this in the book on that, but we can see this works, right? We know that's a load balancer IP because we curl it. We don't have an ingress rule for this. So you would see, what else we could even do on this one. We could look at
we're coming up on the top of the hour. I do want to hit network policies because I want to keep this one to 2 sessions.
Yes, definitely.
I think one of the things that's really cool about this, and you touched on it, if you're running the lab at home, this IP is our Docker network. I can't hit this from my browser running on my laptop, right? That's not going to work. But it's really cool, the fact that hey, I have an IP like that. That's magic to me.
Yep.
But
what you would normally do is in that range, you would wind up putting something in your layer 3 subnet,
right,
like at home. So, or at work. Either way you want to work with that.
You talked about the controller. You talked about the speaker. We create the load balancer service. You talked about the pool configuration. One of the things I actually really like, and I think this is because it's an L2, maybe that's just me being ignorant about networking, but the fact that I can specify specific IP address. I've tried to do this with Cilium's load balancer, and it gets really unhappy if you do a /32, which is a specific IP address. I find Metal LB to be far more user friendly. I don't know, because you use Cilium more from a professional standpoint, right, Scott?
I do, but mostly because I'm a big fan of eBPF and what it can give me for that, especially the visibility and security, right? But yeah, that's really independent from saying the load balancer type. But kind of what we were saying earlier is the CNIs are all starting to include extra features, not just networking. Whether it's a service
Right.
mesh, extended policies, load balancers. That it makes sense, right? Bigger offering. Especially something like Cilium, they make a professional version, right, by Valent, where
Right.
you can get some pretty in-depth views if you pay for the console. It's really cool features.
And then one of the things that like I really like about being able to run Metal LB is that you're talking about a couple of YAML files and you're up and running. If you're like me and you do a terrible job planning your lab network and you want to just, toss toss a couple of DHCP addresses in there and just hope nothing tries to claim it while you're running, it works. It's beautiful.
Until it
And when you
doesn't.
pair that, well, until it doesn't. But you pair that with a local DNS, and you've got a really powerful way of managing your home lab network. Anything you want to show off about Metal LB before we jump into network policies here, real quick?
No, I like this. Like you said, that's the simple part of it. There wasn't a lot to it. And like I say multiple times throughout the book, especially in Istios, if it's complex, if it looks easy on the front end, it's complex on the back end.
Oh
And
yeah,
and luckily, the Metal LB team, a lot of Google people on that, they do all the heavy lifting. Right? It's all on their side. They deal with the announcing, having to do ARP, and down the line. It just makes it easy and free. That you can't
yeah.
beat full open source free, and
No,
it is rock stable. I'm sure it crashes. Don't get me wrong. I'm sure there's things out there, but even at scale, which I have seen, no issues, not any. So yeah. Since
all
we're going
right,
to be a little bit over,
cool.
let's do network policies quick.
Yeah, I like to keep it at an hour, but just since this is the second week, I really don't want to have to go a third week just for network
No, we
policies.
can do this
So
in like a couple minutes because these can get quite
yeah,
complex, right, everybody? So
I mean, why don't you talk real quick a little bit about what is a network policy in the Kubernetes world?
yeah, first of all, why would we even care, right? So base concept of clusters from day one, which should terrify security people, right? And just anybody in general in the industry. Every pod can talk to every other pod in the cluster. Boom, base concept. Is that good or bad? It's great, it works, but you want a micro segment, or you should be, especially in a highly regulated environment. Heck, even if you're not, bad actors, other issues, right? So a network policy lets you control traffic to and from your, I'm going to say pods at this level, right? You can say, okay, cool. They can only talk in this namespace. They can only talk between these two namespaces. Heck, this pod and this pod. Now, this can get complex quick, and it is also is different depending on the CNI. So Kubernetes has its own, which is, as long as your CNI supports the Kubernetes policies, great. However, they are limited to, they deal with layer 4 policies. So you can't use stuff like a host name. That's layer 7. Cilium has a Cilium network policy, which does both. Okay, and there's even other add-ons like KubeArmor that can do both, as well as a host policy. That's like a Linux level kind of app
Right.
armor, right? We'll talk about those when we get to that chapter. So these are something I'm getting really into. Microsegmentation, like I said, is a big thing. Now, as we said, they do get complex quick, or they can, which means you're going to break something. It's great to start with network policies in a greenfield environment. Adding them to a brownfield environment where you've got 6,000 pods running, you'll quickly have problems because you're probably going to miss a policy, right? To help you with some of this, there's actually an editor out on the internet on Cilium's website. It's actually or actually they link to it. So Mark, if you want to open up editor.networkpolicy.io.
Let's see here.
Sorry to put you on the spot quick with that.
Editor.
Yep, .networkpolicy.io.
Oh, look at that. I don't think I've ever actually used this page.
Yeah, this is pretty cool. It's it helps you to create a network policy. The other reason I like this is they say tutorials. There's not a lot there, but I do want to kind of mention one of the tutorials. If you kind of click that tutorial box where it says main tutorial, Mark, this is good for anybody out here taking a look at this, and look at the egress to Kubernetes DNS. It's one of my favorite examples here. So when you create a policy, I'm going to do a high level. We're going to say, okay, we're going to say in this namespace, we're going to limit egress traffic, right? So the pods can talk to, I'm just going to pick one thing, I don't know, SQL Server somewhere. So we simply added, okay, cool. Pods can go to this port, this site or range. Well, the problem at that point is that's all you're allowed, right? You set up this policy, you say that, go to try to hit 80 somewhere, doesn't work. 443 doesn't work. Nothing works. That means kubedns won't work either. So I see this a lot. People make a policy, go, cool, this is great. I'm locked out. I can see it only hitting there. Then they try to connect to a service using core DNS and get not found.
Right.
Actually, not even a not found. They get a timeout trying to hit kubedns because you're not allowing port 53. That's what this example covers here, actually. It mentions how you would fix it. So it's really cool. I mean, it's great for this, just to see examples, but for your own purposes, now keep in mind, everybody, this is an internet site. You never want to put sensitive information in it, right? This should be a generic type of thing. You don't put in there these huge metadata tags that you might be using at work that are,
right.
Sensitive data. There really isn't any big sensitive data, but heck, even
but isn't this probably taken right out of Hubble, the Cilium?
Yeah, it's true, but
it might be taken. If you wanted to deploy Hubble locally, maybe you'd get something similar.
You do, but it's not quite the same with Hubble and the UI, right? That's where they have their whole offering.
That's true.
Hubble's got some limitations, like many of the open sources, that if you want to have a nice front end, you have to get the enterprise version.
Right.
But yeah, it is a start. Hubble does offer some pretty nice. So everybody listening is Hubble's an add-on from Cilium to do stuff like monitor the network traffic. I can say, okay, wait a minute, some pod made a connection to port, 10,028 or something. What one did it? Well, Hubble's got these views based on eBPF, right? So in this policy, we go through the book policies too for everybody, but oh yeah, I see this here, and absolutely, this data plane V2. Yeah, I'm a big Anthos person, so I know all about V2. V2 from Google introduced Cilium over Calico, which was V1. So yeah, definitely. Cloud, yeah, definitely in cloud, you're going to some firewall rules, network policies, even internal though. Never assume you don't have bad actors, right?
Oh yeah, zero trust.
Yep, absolutely. So there's a lot to the network policies. Again, I love having the editor. There's even other products out there like KubeArmor that can watch your network traffic and create a policy for you, right? Again, we'll talk about those in a later session. So in here, you got a network policy object. So you see the kind. And in this example, what they're doing is they're allowing egress to kubedns. So I'm trying, it's hard to see on the screen looking at mine actually here, Mark. So looking at the policy here. Yeah, if I want to talk
Which
about
policy are you looking at? The one online, or
trying to look at one for an easier one to explain. Yeah, let's try that one. Do the drop down of the policies again, Mark, and do the second one.
Egress to pod?
One more up, sorry. When I say second, yeah.
Cross network?
Yeah. I mean, it's just one of the examples. I hate trying to take something that's broken. So the beginning of this, you're going to see it's allow ingress from Prometheus. The pod selector portion are the pods that will be affected by this policy, right? So in this case, it's app Redis. Policy type is ingress. We're allowing ingress from pod selectors that have app Prometheus, Okay, so that really pretty straightforward with it. If you look at the scenario, it will tell you all about here's what you want to do, here's what you don't want it to do. It even at the top shows you the reds, which is all the blocks. It's kind of hard to see this way. There's a lot more we can talk about, but I don't want to keep everybody too long because it's almost 10 after.
Yeah, I mean,
So,
one of the things that I kind of stands out to me here when it comes to the label selectors is if I create a pod and I call it Prometheus in my namespace, have I now opened up access to Redis? Because there's no protection on here on a specific namespace.
right, there is not. By default, though, it should only accept something that's in your current namespace. That's a good question. Mark, I've never tried.
I don't think that's true.
Yeah, I don't know.
I don't think that's true. If you have a namespace, if you have a pod selector and the pod selector doesn't have, now I tend not to do my network policies pod to pod. I tend to do my network policies namespace to namespace. Like if I don't generally like limiting access at the pod level because it can get really difficult to do that granularity and kind of get a diminishing returns a lot of times. So it's kind of like if you go to the and network policy is kind of built off of this. If you go to the AWS security group model, right? You don't want to say server to server limit. You say, this security group can talk to that security group. And because namespace is the boundary, right? The security boundary in your cluster, I like to say, okay, these two namespaces can talk to each other. If you want to limit more than that, then you really need to be getting at a identity level, not at a network policy level, right?
Oh, I would agree because
Because,
then you're
like I
going to run
said,
into a
you
lot of
could,
policies, right? And
yeah,
it just becomes a pain. Yeah, so I'm just kind of clicking some docs, and yeah, I don't see. Yes, because if you don't do a namespace selector, it actually means global.
Yeah. So always include a namespace selector, kids.
Yeah, I don't like the examples of a pod to pod kind of thing, just because of that. Typically, it's there's going to be occasions like that, but this also goes with how you design logically your namespaces and how you deploy. You get a namespace with 300 deployments in it, something's wrong with that design. You probably don't want to say namespace to namespace then, because that means 300 workloads. So it really depends on how you divide logically on your cluster to make that easier. And you should never do that, right? It should be one namespace. I'm not going to say one app, one namespace, but limited.
Right. Yeah, no, and that's one of the things with namespace. Namespace policies that, like, I think the question came up maybe in chapter 1. I don't know. We were talking about, somebody asked a really good question about the namespace policies count as zero trust.
Oh,
and
mentioned it, yeah.
And it's sort of kind of a little bit like it's kind of a gray zone because network policies are really the firewall rules of the Kubernetes world, but they're not purely based on IPs, right? Like they are based on a little bit of identity, right? So those labels have to be applied using an account that has to have identity to be able to do this. Like I brought up the question of the pod label, match label, Prometheus, right? The nice thing about, like, let's say you're in a multi-tenant cluster, the namespace object is not a namespaced with an ed at the end object. So as a namespace admin, you cannot edit the namespace object for your namespace. So it's pretty common to put security labels on there because only a cluster admin or somebody has the ability to edit those namespace objects has the ability to do that, which means you can trust as a cluster manager those labels. Once you start getting into pod selection, though, then it's like, okay, well, who owns the ability to update those labels? So there is a little bit of identity there. But this should be like one part of a defense in depth. It is not it's better than just a straight up firewall rule with IP ranges, but and we'll get into this not next chapter, but 2 chapters. So chapter 5, you really want to be doing an identity based validation when you're talking service to service.
Yeah, definitely. That going to chapter 6, right? 5 is when we get into GSL.
Oh, that's right, because we have
split it
5
up.
is 5 is we're doing global load balancing.
And my apologies to everybody. I actually have to get ready for another call.
Okay.
Running late now.
I think we'll call it a day. Anything else you want to say about network policies here, Scott?
No, it's something that honestly, starting from a cluster, I from day one, I wanted to make a kind of an idea of every new namespace gets a network policy that denies everything, forcing, of course, developers then to loosen up the policy, actually create one, because starting it later is tough. It just it takes some time, right? You started off at the beginning. It was difficult 7 years ago. People were still learning Kubernetes, right? And they still do. Don't get me wrong, but back then everybody was pretty new. So yeah, we never really did, and we, it. Not that there's an issue, but especially in a highly regulated industry, right? People always say Kubernetes multi-tenant, not secure, and I'm like, well, okay, no more, no less than say a VM, because there's breakouts on there too, right? Less common, but you do this kind of stuff, it's better. And I love that it shifts left. Always saying that, right? The developer can own this, right? On a checkpoint firewall, you're not giving a developer access to go in and play with their checkpoint firewall rules. It's just not going to happen. You write APIs, sure, but here it's totally up to the developer to control it. So I think they're awesome to do.
Yeah. Okay. So 2 weeks for networking, not terrible. But we broke this chapter up. So we're going to go ahead and next week we're going to do external DNS and global load balancing. So this, if you're not familiar with large enterprise networks, this isn't really what you think it is. So you're going to have to tune in. And I know Scott just shared one of our followers went ahead and posted a blog post on network policies. So it'd be cool to check that out. Thank you.
Yeah, I appreciate that.
So So any final thoughts, or let's let everybody go for the day?
Yeah, because you know us, Mark. We'll talk about Kubernetes all day.
All day long. All right. Thanks everybody for bearing in, a little over time, but thank you. Have a great rest of your day, and we'll see you next week.
Thanks, everybody.
Where's my mouse?